So obviously the mitigation has to be placed in the context of what the emissions are going to be, and then decide what rates of drawdown are required. And we have looked at this in various other ways already, but in the context of this working group 3 report, we have to revisit it, especially with the illustrative mitigation pathways as seen by the IPCC working group 3. So these are projected global greenhouse gas emissions from NDCs announced prior to COP26, which is argued to make it likely that warming will exceed 1.5 degrees C, and also make it harder after 2030 to limit the warming to below 2 degrees C. In other words, we are already behind in terms of our goals of meeting 1.5 degrees C, let alone wanting to stay below 2 degrees C. So greenhouse gas emissions again in gigaton CO2 equivalent per year starting in 2010. So historic emissions there, and let's say we start here in 2020. The most benign scenario, like the limiting the warming to 1.5 degrees C with greater than 50% with no or limited overshoot. So 1.5 degrees C, maybe very limited overshoot, but mostly trying to stay below. And one would argue that we should have already started downward trend on emissions by 2022. Now, as I'm recording it, I'm in April, and we are not there. So if you look at 2030, where we need to be, it says that the NDCs announced prior to COP26 would pretty much make sure that we're going to miss this and even make it harder to stay here. Okay, so obviously trend from implemented policies is here, which is not at all very encouraging. So by 2030 we're going to be here. By 2050 the range is going to be here. By 2100, if we don't change things, the emission uncertainty is quite large in terms of gigaton CO2 equivalent per year. Okay, not good news. But if we go towards other targets like limiting warming to 2 degrees C with greater than 67% probability, or return warming to 1.5 degrees C with greater than 50% after a high overshoot. So we go past 1.5 and maybe hit 2 degrees C and then come back with at least a 50% probability, and NDCs are retained until 2030. So you can see that would put us here. So that is even higher than the limit to 2 degrees C warming. If we want to hit 2 degrees C, we have to be here. If we go in this direction, then we have to draw down so much that it has to be more than staying on the 2 degrees C pathway. Obviously, we have already kind of missed it, so it's very unlikely after this we're going to stay on this pathway. So of course, you have to remember the technologies to accomplish this are not necessarily already there. These are optimistic scenarios of what we need to do if we want to hit these targets. Okay, so you can see the ranges here for 2030 and policy assessments for 2030. Again, here for those implemented by the end of 2020 are here. So obviously still possible to hit some of the targets, but only in the case of what is not at all acceptable in terms of the global warming targets. If we want to come down to these ranges, we have to be here. Okay, so NDCs prior to COP26, unconditional elements, those are here, and NDCs prior to COP26 including conditional elements. So none of these are going to bring us much below business as usual. So we need to go quickly towards these, especially by 2050. To meet any of these, we have to be down here in terms of emissions in gigaton CO2 equivalent per year, and by 2100 we have to be way down here with negative emissions and very low positive emissions. Okay, obviously it's good to have these numbers in terms of mapped onto the targets we are aiming for, but how to get there is not exactly clear. For that, many scenarios are created from C1 to C8. So here is the again coming into the historic emissions and where we need to be already in 2022. So again, global warming relative to 1850 to 1900 now in terms of warming. So here are our 1.5 and 2 degree targets with C1 and C2. So these are illustrative mitigation pathways with various assumptions on sustainability, on use of resources, and so on and so forth. So lots of details are there in how these pathways are defined. So scenarios range within category 5 to 95% across the median here. So illustrative mitigation pathways and shared socioeconomic pathways, which we looked at as a combination of SSP 1 to 5 and RCP 2.6 to 8.5, right? So all those are combined here. Climate 8 scenarios, uncertainty is shown here. So these are the potential ranges. So scenario range within category 5 to 95% median here. So depending on which mitigation pathway is accomplished and which SSP combinations are accomplished, we're going to end up with these range of warmings. We've already talked about SSP 8.5, which is basically business as usual and very high mitigation challenge because we haven't adopted low adaptation challenge. So we are in the top left corner of the SSP phase diagram of challenges to adaptation and challenges to mitigation. So you can go back and look at that. Obviously, we want to be here SSP 1 2.6, which will keep us below 2 degree warming, and SSP 1 1.9, which will put us down here. So these are the various scenarios that are tested. I won't read these captions, which are pretty detailed with lots of caveats, which you should read if you're interested in the details and this is your area of research, for example. I'm just providing an introduction to the, not even to the whole report, only to the summary for policymakers. Okay. Modeled mitigation pathways that limit warming to 1.5 degrees C and 2 degrees C involve deep and rapid and sustained emissions reductions. Those are a lot of conditions there. So modeled 2019 levels are here in terms of gigaton CO2 equivalent per year again. So net global greenhouse gas emissions, we look at all of the greenhouse gases, CO2, methane, and N2O, remembering that just focusing on net zero as CO2, net zero is not enough. We must carry other greenhouse gases because that will change the time when we're going to hit the global warming or whether we are going to meet the global warming targets or not. So here are the NDC ranges and here are the pathways we need to follow for, again, the various, let me take care of this call here. So the ranges of, again, implemented policies and 2030 pledges, very likely range here. So this is C7 and C8 range, which looks like our business as usual or middle of the range SSP RCP scenarios, and these are the safer 1.5 2 degree C scenarios down here. And similarly for so you have to pay attention to when all of the greenhouse gases will go to zero versus when CO2 has to go to zero. So this is all climate categories, so very likely range. Implemented policy and 2030 pledges, very likely range. Limit warming to 2 degrees C with greater than 67% probability is down here, and limit warming to 1.5 degrees C with greater than 50% with no or limited overshoot, which is C1 in this illustrative mitigation pathway, very likely range. So obviously we have to go in terms of emissions, we have to go negative here. Some of this is very early, by 2038, 2040 or so, for the lower end of the range, or higher a chance of meeting the probability of not overshooting 1.5, with the less likelihood, or the best case scenario of drop is up here. So either way, by 2050 to 2060, everybody has to hit zero. And again, keep in mind the net zero targets announced by the various countries, especially China and India. Similarly for methane and N2O emissions, of course, here we are going from gigaton CO2 per year, gigaton CO2 equivalent, gigaton CO2 to millions of tons of methane per year, or gigaton CO2 equivalent here, and again gigaton CO2 equivalent, and millions of tons of N2O, because those are in parts per billion, whereas this is in parts per million. So obviously how to mitigate these are going to be very different. We talk about carbon capture, utilization and sequestration, and we have talked about various issues, as well as the heavy reliance on CCUS for meeting any of these goals. But how to accomplish these is not simply technology of capture and sequestration. There are various other ways needed to accomplish those. Okay, I'll come back and show the net zero CO2 and net zero greenhouse gas emissions in the next podcast, because I have to take care of this phone call for now, and this is already 11 minutes long anyways. Okay, let's come back.